Hello, in this video I'm going to look at how I used UDP for motion synchronization between my Unreal Engine client and my custom Java server. So this is going to be split into two posts, but I'll cover it all in one video. So the first post, which is this one, will be covering how I utilized Unreal Engine actor components to extract motion information from my player and push it to the server. And the second one just focuses on how to actually integrate the UDP communication into Unreal Engine. So I just simply use the Object Deliverer plugin. So this is the library that I use to actually handle the communication. So you can see that it handles TCP, UDP, shared memory file. So specifically, I just use the UDP. So you can find it over here. It's a free plugin, so it works pretty good for prototyping and stuff. I think for production, maybe you'll want to use something else because there's a couple of issues, particularly with error handling. But for prototypes, it will work pretty well, I think. And as usual, I'll be integrating with my test server, which can be found on GitHub. So the links will be in the description. So do check that out. So yeah, let's quickly begin with a demo. Okay, for the demo, what I'll do is I'll simply print on screen a message that I receive from UDP. So basically my server is running in the background. So this is the Java server, and I have my UDP client configured. And when I receive a message, before I process it, I'm just going to print it on the screen. Because ultimately this is going to be working the same as before, but instead of using WebSockets for communication, I'll be receiving UDP messages, right? So there we are. I'm going to log into one character here and log into another character here. So you can see they've connected up, and now when I'm going to be running around, you can see that I'm receiving messages. So if I just make this screen larger, you'll be able to see some of the messages. So you can see it contains player motion, and there's my actor ID with test character 1, and then the motion updates. You can see the motion is changing as I'm running around. So you can see it's synchronizing between the two clients. So obviously if I'm running on this one as well, you can see the other character moving around as well. So this is the quick demonstration. So essentially the two clients are being synchronized via this custom server, and all of these motion updates are being sent from UDP, and they're also being received in UDP as well. So that's what we're going to be looking at today. So essentially I've created some actor components to handle the synchronization, so both sending the messages and receiving them, as well as actually processing them as well. So yeah, let's get started with having a look at those components. Okay, so perhaps we'll begin with the server connector component. So this is just going to be a raw object, and I will actually just use it as a client, so my UDP client to interface with my custom server, the Java server. Okay, so this server connector is going to be instantiated in my game instance, and this is because the game instance is sort of always available, so I can access it even after I change maps and things like that. So inside my game instance, when I instantiate it, so when I call event init, which will happen at the very beginning, I'm going to construct my server connector and start configuring. So for example, I will first configure my WebSocket, so it contains the code for my WebSocket. And I'm also going to configure the UDP connection as well. Part of my UDP, I'm going to be assigning a random port. So this is not standard practice, right? Normally you're supposed to have a static port, so let's say 8000, and if that's not available, you'll go to the next one, like 8001 or something like that. But because the object deliverer doesn't have proper error handling at the moment, I'm not able to distinguish whether it was actually successful or not, so I'm actually just assigning a random one. So this is a workaround. I wouldn't necessarily copy this part, right, unless you're just doing a workaround with object deliverer like me. So as an example, when you connect or you try and open up multiple Unreal Engine clients, it's actually going to be assigning a port. I think the default game port is 7777. If that's not available, it will increment it by 1 to 7778, right? And it will just keep going based on the number of clients that you have open. So let's have a look at what we have in Create and Configure UDP. Okay, so we'll first go through the create and configure UDP. So we'll need the host that we're going to be connecting with, the send port, and the listen port. So That's the base information that we need, and we're also going to need to make sure that the object deliverer plugin is installed and enabled as well. So this is the free plugin that we're going to be using from the marketplace. So let's first configure the sender, and we're going to do 3 steps essentially, right? The first one is to create the object deliverer manager, and this exposes 2 events, so event on connected and event on disconnected. Now there's some issues with these functions, so this is primarily where I say I faced a couple of issues. So for example, this sender disconnected, I've never seen it get called, so even when it's disconnected, this doesn't actually fire, so I'm not actually able to add any error handling right now. And UDP server connected, so bind event to connected, this always gets called even when I know it's actually failed to connect. So for example, when I'm trying to assign it to the same port, I know it's failed connection, but it still tells me that it's connected. So there's a couple of issues here. So this is primarily the problem with object deliverer. So perhaps this gets solved in the future. But in the meantime, just be wary of that. So the next thing that we're going to do is configure the delivery box object sender, and you can create different types of senders. So at the moment, I'm just creating the string sender. So you can type create delivery box, and you can see the different types of delivery box senders that you can create. And at the moment, I'm only focusing on string types because I'll be sending JSON messages. And next, we're going to be looking at starting the deliverer manager. Okay, so now we basically grab our object deliverer manager and our object sender. The sender specifies the serialization, and we're going to be connecting to this host and the send port. So then you also have to specify the packet rule. And here you can just type create, and it will tell you what kind of packet rules are available. So no division should be the basic default, but you will need to check with your other server what that's configured to be. And now, after executing this, it should trigger this event connected. So this will print. So you may want to check to make sure that's happening. So after you've connected, essentially what we can then do is start sending the messages, which we'll go through shortly. But before that, let's have a look at how we configure the receiver, which will follow a very similar sort of protocol. Okay, so inside the receiver, what we're going to do is create another object deliverer manager. And this manager is going to be configured to be a receiver. So I'm again going to be binding on event connected and disconnected. So again, like I say, this disconnected will not fire even when there's issues. So do bear that in mind. The next thing I do is create myself the string delivery box. So this is the delivery box object for a receiver. And I've got this event to received. So this is the key event which will be processing when we receive a message. So this one will be very important. So bear that in mind. And then I'm going to be starting this service as well. So I grab myself the deliverer manager. So this manager is managing the receiving. I then get myself the listen port. So I create protocol UDP socket receiver. So I add that into the protocol and create packet rule, so no division again. And this object receiver, again, this deals with essentially the serialization. So I'm able to get this received string here for processing. So there we have configured both our sender and receiver. So this is essentially how you use that object deliverer plugin. And from here on, we're going to be looking at the custom components that we've done to sort of deal with that communication flow. So the components will need to interact with functions from this class. So I need one to send messages and the other one to receive messages. So in order to send them, I've got this send UDP message function, which will be exposed to my other blueprints. And all I'm doing is taking the delivery box object sender and asking that to send messages, right? So this is a function from the object deliverer plugin. And again, just to show you where it was configured, this is this one over here. So you can see create the string delivery box. So it's this one here. So this is where it's enabled. So this is for sending the messages. and we also need one to process received. And if you remember, we handled that over here. And what I'm actually doing is creating one of these event dispatchers. And you can see basically when I receive a message, I just dispatch the message over here. So whoever wants to bind to this event will be able to receive that message and process it as necessary. So I'm keeping this quite dynamic so that all of my other blueprints, whoever wants to use effectively this UDP client will be able to do so. All right, let's have a look at how we used actor components to then connect and interface with this client. Okay, so what I wanted to do is create myself this player motion sync component, which I can simply add to my actors. And this component would effectively synchronize my character's motion, right? So I wanted to avoid creating custom blueprints, which will go inside the event graph or certain functions here. This is mainly, I suppose, for refactoring purposes. So for example, if I go ahead and create a new character class or something like that, I'll be able to quite easily transfer this logic across. So it's not going to be really dependent on this particular blueprint. So I'm just trying to follow best practices there. So this is the component that I want to create. So the player motion sync. So you can find that I've created a number of these actor components. So for example, the player motion sync can be found here. And these components, I want them to focus on the logic, right? So for example, player motion sync wants to focus on how to extract the player's motion and push it down to my server, but I don't want it to focus on the network capabilities, like how does the network work, right? So for that, I created a parent class, which is this connected component base, which will deal with all of the network requirements, right? So you'll find that all of these other components will simply have this one as the base, and then I don't need to duplicate any of that logic. So this is the one that I'll be looking at first. We'll have a look at how this is created, how it works, and then how we leverage it from the other components. Okay, so with our player motion sync component and other ones, we know that they stem from this connected component base. So we know that this event begin play is going to be executed. So for example, this is the player motion sync. There's our event begin play, and you can see it's also calling the parent. So we know that this is going to get executed right at the beginning. And the first thing that we want to do is prepare the variables. So some of them are, pretty obvious, like the server connector. We need to populate the server connector in order to start sending and receiving these messages. So the server connector will exist in our main game instance. So we saw this at the beginning where we've instantiated it. And the game instance acts pretty much as a global variable store. So we're able to get the game instance, cast to main game instance, and then we'll have access to our server connector. So I also populate a lot of other variables, which I find useful throughout my other components. So for example, I'll need the map, I need the server name. If the server name is populated, that I know it's not a client, and I get myself the actor ID, for example. So these bits of information I populate when I log into my character. So from the character selection screen, I extract this information and I add it into my game instance to make that usable throughout. And I basically just prepare a couple of variables that, like I say, I'll need throughout my other components as well. So that's my very first function for prepare variables. And then the next thing that we do is register event listeners. So when we're registering event listeners, this is going to be for the components which are listening for updates. So specifically the player motion sync is not actually going to be listening to updates, it's rather pushing them to the server. But other ones will be listening for updates, and we'll cover this in a bit. It's really quite interesting logic, but I don't want to confuse people just at this stage. Let's go through the initial phase of pushing the data, and then we'll cover the pulling of data separately. Okay, so let's now go back to the player motion sync, because the variables that we need, we already saw how they're prepared. So inside the player motion sync, we have this event begin play. We make sure that we call the parent begin play. And what we're going to do is set timer by event. So this is essentially going to be creating a loop for us. which will execute itself every 0.05 seconds. So I can basically customize that to whatever frequency I like. Which will affect the smoothness, right, of our synchronization. But I'll also say, don't execute it more than once per frame, right? That's going to be overkill. Okay, so I'm going to then execute this function to sync the motion. Okay, so inside the sync motion event, the first thing that we're going to do is get ourselves the owner. So remember that these components, they're attached to our player actor. So when we get the owner, we get our player actor. So the first thing that I want to do is get myself the actor's motion. And this motion is effectively a custom structure, right? So this is a structure that I've defined by myself. And what I want to effectively do is get the actor location, get the actor rotation, and get the actor velocity, and populate the fields in my motion structure. So you can find it here. So it has the position information, X, Y, Z, the rotation information, pitch, roll, yaw, and my velocity information, so Vx, Vy, Vz. So I just go ahead and populate those. So this is based on my requirements, so yours could be completely different. So I just basically created this function in a utility class. Feel free to do it wherever you like. And this is essentially how I populate my motion structure, which is the structure that I effectively going to be sending to my custom server. So when I get myself the actor's motion, the next thing that I'll do is check whether the motion is equal to the motion in the previous iteration, right? The way I do that is take the motion and then I break it, and take the other motion and check them field by field. So unfortunately in at least blueprints, there isn't a function to check whether these structures are equal. So I think this does exist in C++, I think, but not in Blueprint. So I basically had to go field by field, which is, not that fantastic, to be honest, but, it's not that difficult to do either. So that's how I've managed it here. And let's see, so the next thing I do, you can see I check whether it's equal to the previous motion. And if it's different, then I'm going to be executing this update player motion, which effectively sends this update to my server. So you can see that this is how the previous motion is going to be updated as well, right? So after the update takes place, I'm going to be updating my previous motion to the current one. Okay, so let's have a look at this update player motion function. So all I need to do here is effectively grab my server connector that's populated inside the connected component base. So remember, this is taken from our game instance. And I'm going to be sending the UDP message, right? So I have to populate this structure, so motion socket message. So I'm following the same sort of convention for my messages that I send to my server. Bear in mind, this is hugely inflated, right? Like in reality, like when I come to optimization, this will look quite different. But again, for prototyping, it's completely fine. I have myself this motion socket message, which effectively contains structure for player motion, which contains, the actor ID and the motion that we've just created earlier. And I convert it to JSON using another asset. I think it's called struct to JSON. So you can see that in the name here. So I basically send this JSON message to my server. So this is over UDP, and then my server goes ahead and processes it. Okay, so potentially one other thing of interest, you can see that when I was updating my player motion, I could update it via WebSockets by simply connecting to this send WebSocket message instead of send UDP message. So from my previous architecture videos, I think I mentioned a few times, I'm trying to sort of iteratively improve it. So WebSockets was just much easier for me to get started with because it didn't require things like session managers and things like that. Obviously for motion, UDP will be better, so that's why I've just gone ahead and do it now. But you can see from at least the UE implementation, it's very similar to before. This is how we send it, and I'll probably perhaps create a separate video on how I handled the UDP comms from my Java server. But you can see that basically I'm going to be reading the value here. and I'll actually be processing it in a very similar way to how I did with the WebSocket messages. But again, I have some other requirements for things like session managers and how I deal with cache, right? Previously, I could store things on the WebSocket cache, but I've now started using the Redis cache. So yeah, that's handled separately, and perhaps I'll have a different video to showcase it. Okay, so now that we've pushed the update to our server, what we then want to do is start synchronizing the nearby players, right? So we're going to create a separate component. So I've called it proxy player sync, which will be listening to the updates for the player's motion, and it will then synchronize these players in forms of proxies near our player, right? So this is the proxy player sync component. So you'll be able to find it's attached to our player character component over here. So it's again as a component, and what it's going to do is it's going to be listening to those messages, and when it receives the motion for nearby players, it's going to go ahead and try synchronize them. Okay, so the proxy player sync component, this will be listening to some updates from the server. So now I want to go back to the connected component base, and I want to check the function for register event listeners, right? So this is the one that we didn't look at before. So what we're going to do here is we're going to create a new parameter called listening update types. So by default it's empty, and we're going to override it in our child component. So for example, the proxy player sync component is going to define some update types that it's listening to. And if it's not empty, it's going to go ahead and bind to the message dispatches from our WebSocket connector and the UDP connector, right? So we grab ourselves the server connector, and you can see that we're binding to events of the UDP message dispatcher, right? So if I go back here, it's these ones over here. So UDP message dispatcher, right? So it's binding to these events. Okay, so what it means is that whenever a message is received, it's going to go ahead and execute this function of can process message. And inside here, what we're going to do is we're going to grab the socket message. So whatever message that we receive is going to be converted into this structure, socket message response. So I'm always following the same structure for the message. I get the message type, and I check whether it exists inside this listening update types. If it does exist, then I go ahead and process the message, which again is a function that's created inside this connected component base, but it's actually implemented inside the child classes. So for example, the proxy player sync. So now if I go back to the proxy player sync and look into the functionality here, you can actually see that the connection layer is effectively abstracted here. All I need to do is effectively override the process message, and this component doesn't actually need to know how the message is received, right? Like where it came from, because all of that is handled by the connected component base component, right? So the main thing that I do need to do, however, is specify the listening update types, which is just configured over here. So I'm not sure if you're able to see it. But I define some class defaults. So this is where I'm able to see the parameters from the connected component base. And I grab myself the listening update types, and I say that I'm listening to the player motion updates, the player appearance, and the remove players update types, right? So those are the messages that I'm listening to. And then inside the process message, I go ahead and put out the functions to process those specific messages. So that's what's handled by this switch string. And you can see that I'm executing these functions here. So perhaps we'll go through the new player motion first. So you can see that from my player motion, I get myself the motion information. And specifically at this point, I'm just interested in the XYZ coordinates. So I can actually take the pitch roll yaw and add it here as well. But you know, for now it's enough for me to just add the XYZ, because I'm going to keep this actor hidden in game as well until I've received the appearance information. So we haven't looked at that in this particular video, but the server also evaluates what does the character have equipped, if anything, and it will also send you updates about its appearance. So that's what happens. So then once I've spawned this actor, what I go ahead and do is add to my synced players, and this has a different data type, which is a character data structure. So again, it's a custom one, so let's just find. Okay, so is this one here. So it contains the player motion. So this is the message that we get as a response. Account character contains the appearance information. The proxy character is the player proxy actor reference. And then I also added one for appearance sync required, which is a custom parameter. It's just a Boolean, which tells me that I'm still waiting for appearance sync. You'll see that in a moment. So let's go back to here. So that's what I added here. So when I spawned it, my appearance sync is not required. This is like a false Boolean, but I populate the player motion and the proxy character because that's what I have so far. Okay, so now that we've spawned the actor proxy, we can have a look at what happens when we're handling existing player motion. So inside here, we basically know that the data exists inside the synced players. So we're able to find it based on the actor ID. And we need to update the player motion, right? So this is what this one really looks at. So there's two flows here. So one is if the appearance sync is required or not. So maybe I should come up with a better name here. What the appearance sync required really symbolizes is that I've received my character appearance before I received my motion information, which can happen. Because the two functions are asynchronous. So if I've previously received information about appearance sync, that basically means that my actor hasn't been spawned yet. So all I do is basically ask myself to spawn the new character by processing the new player motion. And I've just received the player motion, right? Because I'm saying that it exists inside the synced players, and it's the motion update that I got right now. So I handle myself the new player motion. I then force myself to handle the player appearance because I didn't have the actual character spawned before. So now after spawning it here, I actually have the character spawned. And then finally, I can just call itself back right to where it was here. So handle existing player motion. And next time it's just going to go into the false category, right? So it's basically a long-winded way of synchronizing itself. So if I received the character appearance information first, and now I got myself the motion information, I'm going to go ahead and spawn that actor, handle the appearance, and then go back to itself, and then next time it'll come back here. Okay, now that we're back to updating the existing player motion, the main thing that I want to do is get myself the motion structure that you saw me populate earlier, grabbing my proxy player and effectively doing the inverse. So now I want to be setting the proxy player location, rotation, and velocity. So you can see I'm not doing it directly. I'm specifying the target location, target rotation, and target velocity. Because I've created a smoother component, which is again going to be attached to the proxy actors. And what I'm going to effectively do is smoothly try to get to those targets. So you can see that it's only going to be doing the smoothing if it's authenticated, or rather not authenticated as a server, because the servers don't need any smoothing. So if you're a client, it's going to be trying to smoothly reach to those targets. So you can see there's my position smoothing. So I'm going to grab myself the target location, which is assigned to my actor components, and it's going to be reaching them via these vinterp2 functions. So there's actually a separate video on this as well. Otherwise, without this, it will look a little bit jittery. So I'm trying to smoothly get to those positions, but it's going to try and do it fairly quickly as well. So that's what's happening there. So this is how I'm updating the player's motion. Okay, so perhaps to finish off the video, what I'll do is I'll also go through the other two functions as well. So I think the process appearance is not technically in scope of the motion updates, but you might find that interesting. So I'll just go over this as well. Okay, so the process appearance will take the message that we get from the server. So this message contains the player data. And again, I'm sending it as a batch update essentially, right? So it can contain multiple players and their appearance information. So this is a map of strings to values, where the string is the actor ID and the value is this account character, which is a structure mainly containing the appearance information. So I take this variable and I'm going to iterate it using the keys. So I iterate it and I check to see whether it already exists inside my synced players. So if it exists, I go ahead and process the appearance, but if it doesn't, this is where I create and use that appearance sync required functionality. So basically, I take that account character, this contains the appearance information, and I'm going to add it to synced players, but I don't have the proxy yet. That's going to be created when my motion information is received. So I know that later on I'm just going to ask it to call the handle existing player appearance, right? So again, if it does not exist in my synced players, I'm going to add the structure where I basically specify the appearance sync is required, which will again recall this function in the near future. And if it does exist, then I can go ahead and handle existing player appearance. Okay, and inside the handle existing player appearance, what we're going to do is grab our synced players and find the data based on the actor ID. And what we want specifically is this account character and the proxy character reference, because from account character we get the appearance info, so you can see that here, and we take the proxy and we set the appearance structure in it. So this is custom fields that I have in my player blueprint, so in my proxy character blueprint as well, and we ask it to resolve all appearance. So this is documented in a different post on different videos, but this one basically goes through each of the modular components. So for example, it will go through the hair, the face, the body, and it will update the meshes and materials based on this appearance information structure, which is received from the server. So no, go back. So once that's processed, I can go ahead and set actor hidden in game to false, right? So if you remember at the beginning, the actor is hidden, and then after processing the appearance, I can make it visible to the game again. So this is how we process the appearance. And then finally, the last thing is to process remove players. So this one should be relatively simple. When the actors go too far away, so I stop synchronizing them, the server will automatically send me a message to say that these players should no longer be synchronized on your client. So I go through the synced players variable again. I find each element in there. So again, I grab myself the proxy character and I simply destroy that actor. So I don't want to have that in memory. Once I destroy it, I can go ahead and remove it from this variable. So I remove it based on the key. So that's all I need to do when the player sort of goes outside my view. So I no longer need to synchronize it. So I suppose I've gone through the entirety of synchronizing the player's motion and synchronizing the proxy characters that I also see. So that's the main bulk of it for this episode. And perhaps in the near future ones, I'll also cover some of the back-end implementations as well if people are interested. Okay, so perhaps as usual, I'll finish off with another demo. So what I'll do is I'll add another print string for when I'm sending out the messages. And this one, I'll make it in a sort of pinkish color. So I'll also have it print only for 0.2 seconds so that it doesn't sort of blow up the screen. And as before, we've got another print string when we're receiving the messages as well. So this one's going to be in a blue color. So I'll go ahead and click play. So in one screen, I'll log into one character. in the other to another character, and you can see that I'm basically getting a lot of these updates. So one of them is sending the message and the other one is receiving the message. So only one of these clients is actually sending the message and only one of them is receiving, but it's running under the same thread, which is why you're seeing both of these messages. So what I'll do is I'll also show you when it's running not under one process. So basically you'll spin up a separate process to handle the other one. This will take a little bit of time to open, so I'll go ahead and pause this while it opens. Okay, now that's that open. So what I'll do is I'll go ahead and log into this character, log into that character, and you can see that only one of them is going to be sending the messages and the other one's receiving, and vice versa. So this one, there's going to be some optimization. So while one of the screens is open, is going to apply some optimization. So it's going to be very jittery here. So you can see like that, but it is working as expected in the background. So we can see that basically only one of these clients is sending the messages, and the second one through the player's proxy sync component is receiving those messages and updating the proxy characters as expected. So yeah, that's it for this video, and thanks and see you next time. Bye bye.